Okay, so this last video is going to be a little quicker than the other ones, and it's just wrapping it up on the more analytical observational epidemiology studies. So again, what makes it observational? Nobody's assigning exposure, and where we left off was covering the cohort studies. So we finished up case control, and we're going to talk a little bit about the cohort studies now. So with cohort studies, you have a group of people who are healthy and susceptible. Maybe they're all going swimming at the beach or planning to, and some people go in the water, some don't go in the water. They just all show up at the beach, and we didn't know who was going to go in the water or not, but then they tell us by the time they left who went in the water and who didn't. So then we can then mark which group they were. So we didn't assign them. We just let them choose their own exposure, and then we followed them, called them back maybe a week later to see if they had any diarrhea or not. Maybe in this case there was 1, 2, 3 people out of the 5 that got sick. This one maybe only 1. We make those comparisons, and then we can do odds ratios or risk ratios for different diseases and different follow-up periods. You might do rate ratios. It's really up to the folks doing the study and their choice and data analysis and study design and making it easy to interpret. So we're going to speak a little bit about cohort studies here. So the different kinds of cohort studies, we talked about prospective, retrospective, and ambespective. The cohort itself is just a group of people generally attached to a certain period of time, the people that all are enrolled. And in the case of a prospective cohort study, the predictor is measured before the outcome. So maybe we're interested in whether or not people get diarrhea after swimming at the beach. So we enroll everybody in the study who shows up at the beach. We know who went swimming, we know who didn't go swimming, or maybe we know who went swimming in the water on the days that the water was bad, and we know who went swimming on the days the water wasn't bad. We call people 7 days later or 10 days later to find out if they had diarrhea or not. So ideally, they all showed up at the beach and were healthy and susceptible, and then we measure the incident disease later. This is the prospective. A retrospective design, we need to know when they were healthy at time 0 at the beginning of our time clock, and then we might figure out something about their exposure, through records, and then know when they actually got sick or when they had the outcome of interest. But the prospective cohort studies are the design that most folks often think of. So you have big studies like the Framingham heart study where maybe people are enrolled at birth and we might follow them until they have a heart disease or maybe even later. So we gather all these years of observation before they ever get sick. The intro to biostats class, we're not going to get into the more advanced types of analyses that are possible for long-term survival studies, things like survival analysis and all that. We're not going to do that for us, but you can take these types of studies though and still do chi-square test, exact test, logistic regression, odds ratios, which you can do nested case controls. So there's a lot of different types of statistics that can be done on cohort studies pretty easily later on in the class. Many folks know, hopefully from your epidemiology class, how to calculate an odds ratio, how to calculate a risk ratio, how to calculate a rate ratio. I'm not going to belabor the hand calculations of those, but I am going to refer you to the videos that we have online about how to make interpretations based upon the actual 95% confidence intervals that go along with those, because in case control studies we get odds ratios, in cross-sectional studies we get prevalence odds ratios. Those ratios are not really worth anything unless you've got the whole 95% confidence interval, because a small study does not, um, produce the same amount of error as a large study. A large study has a lot smaller amount of error. A small study has a lot of error. And the ability to make conclusions in statistics, we rely on our confidence and we rely on probability. And we'll speak more to that in this upcoming section, either for this week or maybe you can use it next week. So you should be familiar with these terms: odds ratio, risk ratio, and rate ratio. You should know that those things can all be calculated from a cohort study. But the interpretation of whether or not one is significant or not based on the 95% confidence interval and how to communicate those terms, they're all pretty similar. So I strongly encourage you to watch those videos that you'll be directed to on interpreting odds, risk, rate ratios, as well as you can even use it to help out on hazard ratios. Just briefly, you should remember from epidemiology that prospective cohort studies are really good at being able to get healthy people who don't have sickness before, and that reduces that bias. You can get a better measurement of the exposure before the disease starts. So it's really good, but it's expensive. This is the most expensive type of epidemiological design in terms of the number of participants and following them, because if you have a similar number of participants in a cross-sectional study, you only have to follow them one time. These folks, you have to talk to them at least twice. So time is money, so these take more time, and you can measure a variety of other exposures or confounding variables, but you're often limited, though, to one outcome of interest to start with. But there might be other outcomes that show up that you can still study. So retrospective designs, again, they may be cheaper and not take as much time as prospective designs, but you would still need to have some sort of access to the records or something that tells you when people at time 0 were healthy and susceptible to the disease. I'm not going to spend too much time on the actual how to carry these out. Again, this is biostats, not epidemiology. For studying rare diseases, you'll see the case control studies are the best design. They're a lot better than the cohort studies and the cross-sectional designs. The cheapest types of studies to do, ecologic studies if the data are available but they don't provide the best results. Then maybe cross-sectional and case control are affordable. A most expensive to do would be the cohort studies. The quickest to do, if you've got the data already available, an ecologic study would be the quickest to do. If those aren't available, next quickest would usually be a cross-sectional study, but if it's a rare disease, that's pretty worthless because you're not going to get enough people. To study something, which one's going to require a larger sample size. If you were comparing cohort studies versus case control studies, a cohort study is going to require more people because you just don't know who's going to get sick and who's not. Case control, you find your 40 sick people, compare them to your 40 healthy people or something along those lines. So studying rare diseases, again, case control is better than cohort. Cheaper to do. Case control is going to be cheaper to do than a cohort study. Quicker to do. Case control is going to be quicker if the records are available than a cohort, than kind of waiting for people to get sick. Which one's going to require the larger sample size? Again, if you've got access to hospital records, case control study, you can get your own results pretty quickly. Cohort studies, you're going to have to enroll a lot of people and then see who gets sick or who gets the outcome that you're interested in. Which one does a better job detecting the sequence of events leading up to a disease? So case control or cohort's going to do that. Which one? So case control, we only know that they had the disease and that they had maybe an exposure of interest. or didn't have the exposure of interest and had the disease. Whereas the cohort study, we actually know the timing. We know that they were healthy and susceptible, then we measure their exposure, and then we know whether or not they got the disease or not. And then what are the different measures for each design in terms of risk measures that the statistical tools can give us. So we could do the calculations or use the software. We'll use the software for one of these. And the risk measures would be for case control study as well as for the cross-sectional studies. We can get an odds ratio. And we can also get odds ratios for cohort studies. But cohort studies will also permit us to do risk ratios, and cohort studies will allow us to also do rate ratios. So case control and cross-sectional studies, usually we're doing odds ratios and prevalence odds ratios for those. Cohort study, we can do odds ratio, risk ratio, rate ratio. So that concludes all on those. So hopefully that's enough on the study designs. We'll start to get into the action on using the software here in the upcoming videos as we discuss the different distributions of data, measures of central tendency, and all of that. So hopefully this was all review. Thank you.